Recording and broadcasting. All right, thank you everybody for coming to the Digital 360 Summit second session of the day. This is the Smart Networks keynote and panel. You are in the right place. We have a phenomenal team of speakers, superstars, and I want to thank them all for being here today, starting with Carolyn Chang from Intel. Hi, Carolyn.
Hello.
We got our moderator, Dr. Stan McClellan. Hi, Stan.
Hello.
We got Mar Terrace from Anterix. Hi, Mar.
Hi, good afternoon to everybody.
We got Steve Lowe from AT&T. Hi, Steve.
Hey, good afternoon, everybody.
We got Jesper Eriksson from NovFlow. Hi, Jesper.
Hi, everyone.
We got Jon Vestal from Telstra. Hi, John.
Hi, everyone.
We got Ty Roberts from Itron. Hi, Ty.
Hey, everybody.
And we got Liam Quinn from Dell. Hi, Liam.
Hi, everybody.
Well, I'm delighted that you're all here, and I just want to kick things off by introducing your keynote, Caroline Chan, who's been gentle enough and courteous enough to dedicate some of her time to us today. And I'm gonna basically roll over and start running some slides and share my screen. And let's go and do that.
Great. So while you're doing that, I am looking forward to sharing this. I'll kick things started, but
can you guys see
we
my
have a, yes.
Good.
Do you see the full screen now?
No, it's still edit mode.
Oh, we're back to the same thing. Okay, try again.
Still edit mode.
Sorry. I thought I had it. Oh man. Let me start sharing again. My apologies. Yeah. Why isn't this working? Okay. There we go. It's the second desktop. Do you see it?
That was perfect.
Yay.
Yes.
It's working.
Yes.
All right.
All
Okay.
right, Caroline, you're on.
Okay, so I want to share some of Intel's view, and I hopefully will resonate with everyone, is that what we see, how the smart networks working with 5G. What have we done? What have we learned so far? And what is the future looks like? Next page, please, Andreas. So I'm not going to draw too much on it because, this is the 5G vision, unless you've been sleeping under a rock. Maybe some of us have been since we went into this pandemic. That 5G, it's different than the previous generation because it's meant to be a future where compute is everywhere. It's fluid, and it drives the intelligence network that used to only reside in the cloud. But we wanted to bring that anywhere in the network and touches upon not just a smartphone, but all of the devices that's how that drives a smart society concept. Next page, please. So what is really driving the need for 5G? Is 5G simply a technology looking for a market? Or is it 5G that is a true demand? I think that's a $1 million question. I just saw a Dell Auto report saying that the 5G is actually, believe it or not, being rolled out a lot faster than previously anticipated. Everyone thought this COVID will actually slow it down, but it actually did not. It actually drives us forward. So there is, we believe there's a cause and relationship why this issue that we are facing in society actually drives the 5G forward. we see this as not just a, say, connected smartphone. We see this a lot more as the need for the video streaming. Everybody's working from home, and the need to make an automation roll out much faster than we have seen before. So the bigger picture is that 5G becomes a catalyst of the new paradigm of compute. What we used to see is can you go to the next page, Andreas?
No.
The bigger picture is that 5G used to be just connectivity, just the 4G, 3G just drive connectivity, and we don't really look at how this impact the devices that they have, because we all know at the end it's an Apple device, it's a Google device, it's a Samsung device, and so on and so forth. But because of 5G was designed from the get-go to be different, from the get-go to connect more than the consumer devices, it drives a fundamental shift in how the protocol was designed. As a result of that, you've seen a heightened interest from all sides of the ecosystem, not just the operator, to the carrier. They play a vital role in rolling out 5G, but we also see heightened interest from the cloud service providers, from the enterprise CIOs. So really started shifting how the compute being deployed. So that's really the bigger picture that we see. That why Intel believe that edge network and enterprise really started getting connected together. Next page, please. So we cannot talk about 5G without talk about the foundational network transformation, the NFV and the SDN. 10 years ago, we started the idea that software-defined network and the network function virtualization, which carries the software throughout the network, it really is a foundational for the future of the connectivity. This has become suddenly what 5G builds upon. If you imagine a world that you have connectivity, but you don't have the many aspects of a network that's built on compute and storage, you will not have this result that you will see today. You will not see some of the use cases we'll go through later on. Because of the fact that we have softened the network, because of the fact that the network is really an open, cloud-like, software-defined platform, enables things like analytics running on the edge, enables AI, enables network slicing, you really start driving this idea that intelligence is what you needed. It gives you all the flexibility and agility. Next page, please. So what is from the standards perspective, what's a 5G? What is evolutionary and revolutionary? So what we have seen so far is that the current release out there, we're seeing a lot of eMBB, the mobile broadband. The next release that's coming out already, excuse me, release 16, started addressing URLC, started addressing a lot of industrial, the smart manufacturing, and it could not come sooner given what we're facing in the society, economy as a whole. The smart cities becomes from a concept to start into a trial. And the next one is even more exciting, the release 17 that's coming out, the cars, the smart agriculture, the fact that the driving FCC giving out the precision agriculture. And Andrea, that's how you and I met. We were actually on the FCC panel at CES, talk about how does this smart agriculture being enabled, not just by connectivity, but also all the cloud that can be connected through this 5G network. So if you believe this vision, it's actually significantly increased the total addressable market beyond our current smartphone. So if I would go to the next page, I'll go a little faster and start looking at some of the learning we've got. So I mentioned at the beginning, we all have this 5G dream. Would anybody actually willing to pay for it? So recently, I partnered with IGR out of Austin, and did a survey of 70 CIOs from enterprises that have at least $2 billion revenue. These are all in the United States. Unfortunately, given the situation that we're facing, we're not able to travel, so we focus on just the United States. We asked a series of questions, and some of the numbers that came back, the results that came back, it's actually quite interesting. The top 3 reasons for the enterprise wanted to have enterprise network is squarely on connectivity to new devices. Network security comes actually very high and in the need for that. The cost of upgrading for networks is also one of the top reasons why they're considering. And interestingly enough, they said that 89% 5G is required or preferred, even though a lot of the use cases today, you would think that LTE is sufficient. But because people want to drive a evergreen, they want to future-proof their network. They don't necessarily want to deploy a network in the enterprise and later on have to upgrade. The other part that I thought it was very interesting was we asked them who do you trust to deploy and manage your 5G network? The cloud service provider comes out on top with a close second from the carriers. So you really see this game changer because you ask the CIOs, because they traditionally actually worked quite closely with the cloud and the multi-cloud environment. That becomes a very much top of their mind. So the fact that cloud coming to a network, I think is undisputable fact. That's something that's going to come, and all of us need to figure out how do we work together from the telco side to the enterprise and to the cloud side closely to make this moving forward. The interesting thing is we asked them how much money you want to spend. They actually willing to spend somewhere between 5 to 10% of IT budget on this 5G network. So some of the interesting facts, and we're going to go through an interview process to dive into more of the details next. So next, please. So this is a little bit of Intel marketing, but I won't go into any detail given that the audience that we have here today. Needless to say that the Intel portfolio has both our device and IoT side, because we have IoT group. We partner with our network group, and then of course our heritage actually coming from the cloud. Interesting enough, when we started this network function virtualization, we have found that majority, the numbers that came out was an extremely high percentage of the 5G core are all virtualized. Some may even say it's 100%, but it's really hard to say that 100% that's the case. Publicly we say it's a very, very high. We're seeing a lot of the virtualization started coming onto the edge, even onto the access. So there's a lot of conversation going on around O-RAN, Open RAN. It's really driven by the desire for the network to be more accommodating, to be more acting like the cloud, driving both the cloud economy as well as the cloud practice. If you think about some of the application later on, we'll talk about in the panel, will be running in the software. So having a white box, having an open, interoperable platform is a lot more advantageous. So next page, please, Andreas. So we can't talk about 5G and edge together really without being talking about what the value proposition is. We've seen 75% or so of the enterprise generated data will be created and processed outside of centralized data centers or the cloud by 2025. And that number is very significant. It actually impacts how we turn out our roadmap, what kind of silicon and platforms that we are designing, because we clearly see the fact that a lot of data will no longer just residing in the cloud or even consumed in the cloud. So a lot of latency sensitive applications, a lot of storage will be running on the edge throughout the network, and the growth is no longer just say, if I'm having the data growth, I need to open up a new data center. You see a lot of the the shifting really is outside of the data center, and including the AI aspect. So that's another thing, another key factor that impacts us. So next, if you, actually just go to the next page, we talked a bit more about what we see, how the 5G and AI are really linked together. When we start talking about 5G, a few years ago, we really talked about connectivity, millimeter wave drive the most spectral efficiency. We're still talking about that, but half the time when we talk to the streets, when we talk to the analysts, they want to know how does 5G and AI really come together. It's almost never been a conversation we have on 5G without talking about AI and edge analytics. It's not surprising, 2035, 17.9 trillions of the global GDP drives from that. We see that today in Asia, led by China, Japan, and Korea. We see that a lot here in the US. Almost every day you see a news about a industrial, retail, healthcare leveraging AI to run their business. The fact that they generate so much data, you got to have learnings, you got to have trainings, you got to have analytics running. Inevitably, you need connectivity. Inevitably, you need secure connectivity, and the type of bandwidth that you need and the latency that you will require truly being driven by many AI use cases. So the chart on the right, you see the yellow, the orange, or I should say the burnt orange and the red. You see how the trajectory is really driving. AI becomes a foundation to drive all of the uptake of the 5G, and then the productivity gain. The productivity gain is probably the most jarring of all. The fact that once you have 5G AI, the productivity gain is so significant. It really started changing our society, where the jobs will be, and how we conduct business post COVID-19. Mm-hmm. I think that number to me is the most challenging. So you can go ahead and go to the next few. I just wanted to share some of the things that we're working on, even during this whole shutdown period. Actually, I have to say, our team, if anything, even busier, because we're seeing tremendous amount of demand coming in we initially didn't think the healthcare was going to take off so early, but man, there's that ever. Needing the data, needing the information, how to quickly, giving out diagnosis, remote telemedicine really started coming together. So the operators like AT&T, we've been working quite a bit with them, Verizon and T-Mobile and so on, and not just here, but also outside of US. So let's go into some of the examples I want to go through. And next page, please. So the first thing we'll talk about is industrial. We always thought industrial would be the first one out of the chute to come into 5G. I would say that with the shutdown, it actually significantly increased, especially with the release 16 that has the URLC, has the time-sensitive network element being able to combine that aspect, the TSN aspect, together with the URLC, really ignited the industrial adoption of 5G and the need for their own private/enterprise centric network, rather than just from an outside network and serving them as a use case that they really want this dedicated to them. We've seen automation significantly. We've seen running the logistics, ensure the supply is secure. And then the other thing was the safety, the social distancing, the remote distancing. We have quite a few cases we're partnering with the OEM to deliver that to the factories. Next page, please. I think this one will actually show some of the things we've seen. Number one we've seen is that 5G and Wi-Fi really come together. It's never just a pure 5G or pure Wi-Fi. we just recently did several cases with a company called Itron in Italy, which they are manufacturers, but they also supply the manufacturing technology outside. We talked about how 5G enabled them to fully automate their factories as well as export the technology to their customers. We just announced a blog with the Bosch, talk about how we intend, Intel and Bosch together intend to take the 5G, the AI, and edge analytics to drive their to really drive up the productivity. We see in Asia, especially the AGVs, are significantly, the usage of AGV significant uptake. So we generally see 5G really runs things that moves around AGVs and mobile devices. And Wi-Fi still has a very valid place in all the fixed devices. Anything that requires significant amount of SLA, they're willing to pay for the 5G, but they keep the Wi-Fi or many of what they already have, like some of the sensors that are not moving. There's already been a provision. So we do see quite a bit of 5G and Wi-Fi coming together. Okay, next page, please. The other thing was retail. Interestingly, now retail, before there's always this physical world and digital world. With this COVID, it's even more pronounced. So if you go into we used to have this omnichannel experience. We actually partner with Dell on this, where you go into this physical store, you want to be able to see what else is out there. We see that tremendously grow. And the other thing is frictionless checkout. It was something that we started working on. It has to take on a life of its own. To be able to go in and have a smooth transaction, let's say in a restaurant or in a fast food place, but really you don't minimizing the interaction with another human. That ecosystem just exploded, and the need to have a secure transaction, you asking what is LTE or 5G, it doesn't matter, but the experience of having a guaranteed secure transaction as a shopper coming, seeing what the menu is, to be able to find something and check out without even having to touch another human being, interact with another human being, that really, really has come through. Next page, please. So as a result of that, I think I mentioned before, again, very much the 5G and Wi-Fi really coming together, a frictionless connectivity, a trusted, secure transaction, and something that's audible if something goes after a post-transaction. All of that, the multi-access aspect of the network really come into pronounce. They don't really ask whether it's Wi-Fi or it's 5G. What they want to do is a consistent connectivity for the right type of transaction, and you have CBRS now becomes available. We see a tremendous uptake on the CIOs for this, but at the end of the day, they need somebody to deploy the network. They need someone to manage the network. So the roles, there's a key role for the connectivity provider like Telstra, like AT&T to will play. And many times we partner with our current ecosystem to provide this kind of network out there. Everybody always talk about TCO, but under this, because the retail, really the first thing they ask you to do is, how do I protect my customers? How do I protect my employees? How do I, at the same time, the data is even more important. Every transaction to them is a data. What sells, what don't sell. And because supply chains are such constrained during the crisis, all the use cases that we talked about before, last time we met in Vegas, Andres, really take on another aspect. We see a lot of uptake in the retail space. Next page, please. Media. So everybody's at home. The streaming and the gaming. I think there was a recent, and I forgot who actually just giving out that the gaming is take on a huge uptake. We can see that in our consumption. We can see that in in the category that we sell, and the video streaming and efficient production, again, minimizing the human interaction really becomes very important. We have done things with AT&T before in the PGA tournament, and that using 5G as a production instead of all the wires coming around, and that itself has really moving forward. So let me, if you go to the next page, I'll go through some of the examples we looked at. So the AR, VR immersive experience, because now people might not be on site. How do I enhance the consumer experience when I actually go into the amusement park? Anything that comes in, we actually, right before this shutdown, we have put in a private network for American Dream, which is a retail shop, but has a lot of entertainment aspect, roller coasters and skiing stuff, skiing and water park. All of that now, they want make it into an AR, VR experience. All of this real-time visual processing, and as well as operation and control by the venue owners. Think about what has happened to all the sports venue. Everything becomes, there's no spectators. But at the same time, you want to bring that experience to the players, and you want to bring the experience back to the audience. So there's a lot of work going around saying, how do I pipe in some of the noise? How do I bring the fans virtually onto the arena, whether it's a concert or it's a sports game. A lot of times 5G becomes a conduit, but it's really the application that runs on top, the ability to drive in the AR, VR, or even mixed reality that really becomes the end goal. So the connectivity piece, the AI, the edge, all really coming together. I think next page. Yeah, so the last example I just want to share with you is medical care. I was the first one. I think I might even said it, Andreas, and said that I would forget it. I will never do any VR surgery. The telemedicine thing is 5 years from now. The reality is, it's actually here. We're actually seeing a lot of that. We actually wound up, the partnership that we have, the medical care got significantly accelerated. If I go to the next page, so in terms of the use cases, a lot of the patient guest access is still very much done without human interaction. All the clinical environment has driven a lot of connectivity piece into this. The 5G becomes a dedicated network for critical patient care, asset tracking. Wi-Fi still are the fixed assets, things that put in there, nobody's ripping them out. Any non-mission critical devices still resides on Wi-Fi. A lot of backup communication resides on Wi-Fi. But with 5G, they find it even more important to track where the patient is, to track where the assets are, some expensive equipment that today might not always have people watching it. So we actually seeing the significant uptake on the healthcare side. Next page. I think this is my last summary slide before I go back to the panel. 5G is way more than the connectivity. And what we're seeing is that the significant network infrastructure market being transformed from fixed assets to fixed appliances to a soft SDN type of virtualized ones, and driving more and more into the cloud native. We're seeing the cloud and the carrier really coming together to driving from the same cloud economics. And Edge really provide a very significant opportunity for the enterprises, for the CIO. So we look into, as Intel, we're looking forward to partnering with everyone in the ecosystem to start driving this 5G as a benefit to our society, combining with the Edge and AI growth. So that's my quick run through of what we see, and I'm looking forward to a panel discussion. Thank you very much.
Wow, that was intense. That was really, really interesting, really interesting. Andres, I'm going to jump directly into the panel here, if you don't mind, because my brain is humming. That was an outstanding presentation, Carolyn. We didn't get a good introduction of you in the beginning, but this has been Carolyn Chan, Vice President of the Data Platforms Group and General Manager of the Network Business Incubator Division at Intel. So we're talking about some pretty authoritative concepts there. And as we jump into the panel session, I want to kind of bounce off some of the things that you brought up there, Carolyn. And right now, I'm actually going to throw it, because of some of the stuff that you were talking about, I'm actually going to throw it over to Liam Quinn, because I've seen a similar presentation from Liam Quinn at Dell. Liam Quinn is Senior Fellow and Senior Vice President at Dell Technologies. Liam, are you there?
Absolutely. Hey, Stan.
What I want to hear some of your bounces off of that with respect to client-side innovations and edge compute.
Well, a great presentation by Caroline, as always. So thank you, Caroline. For Dell, 5G is really it's an exciting time for us. We're doing a lot of innovation down on the client side. Now I'll talk to that next. We're also taking a lot of our assets over on the enterprise side around storage, software-defined networking, x86 servers, as well as virtualization and features from VMware as part of the working with the telcos around the world in a prioritized basis on helping them transform their network. So across the stack, Dell is very involved with the telco providers as well as partners like Intel, and what we do down on the client side, and we're driving a lot of innovation there. We've got a number of experiences that we're driving and focused on, and that's around always connected, always available in a very secure way, which means we've got to be very creative in the way we innovate on Wi-Fi capabilities as well as the applications of 5G and how we use it. It's not for all platforms. I think over time it's going to phase into and across different platforms on both commercial and consumer side. But we're focused on a number of key use cases right now. Caroline touched on a couple, like first responders. I think that's an excellent use case there, where you need the low latency, high bandwidth capability for triage at an accident site, getting that data in a mobile way up into the ER room or to the staff there. And then even on the ambulance itself, you can embed devices there where it actually retains a lot of data for further analysis on either from insurance perspective, patient care, and when the ambulance is docked at night, that can actually be uploaded to the cloud. So again, 5G is one of those key enablers that is not possible today in that type of usage model for existing technology. So that's one. I think gaming is a very interesting one as well, where again, you need the capability of the features of 5G, and I think a lot of people talk about bandwidth and latency and capacity support, but I think one of the key features of 5G is its network slicing capability, where in a software-defined world, you can actually allocate as a service slices for different type of workloads, because not all workloads are the same. The new 5G environment has got to be able to support multiple diverse workloads. And the inherent feature of network slicing is going to be a key asset for that. You can sort of dream outside the box and think of, imagine if you could extend that from the radio tower, that type of feature down onto a client device, whether it's an AR headset or VR headset, other type of IoT devices, and or mobile computing. Think of the creativity that you can do in that space as well. So let me pause there, Stan.
Absolutely. These are some spectacularly interesting topics. Steve Lowe, AT&T. Steve, as somebody who comes from the provider side, the network side, does it bother you to hear these discussions about privatized networks that'll do an edge-based computing and stuff?
No, absolutely not, Stan, but thanks for asking. As you can imagine, AT&T has a very heavy investment in 5G. I know some of us have been quarantined, but even with the quarantine, everybody knows that the investment AT&T is doing with 5G and the ability to do the compute. My responsibilities with AT&T are more focused on the utility IoT capabilities. And so when I think about 5G, I think about how can a utility deploy 5G and how it will benefit them. I think currently most utilities are looking at a private network. As I know that many utilities like to have spectrum, something that AT&T has taken a run at in the past is providing spectrum to utilities. But I think that more importantly, that utilities are looking at a platform that can support their field area networks, and 5G can play a role in that. I think that one of the limiting factors with the 5G for any industry, and specifically for the utilities, is the manufacturers that they work with, and having a device that is 5G compatible. And so there's going to be a bit of a lag, I think, in the utility industry with the ability to have 5G technology, just because they're just now getting to the 4G LTE realm of things. And I really think from a 5G perspective is where you're going to see the early adoption is from microgrids, and where that they can start to do peer-to-peer relationships. And I think that's something as we start to look at distributed generation, which seems to be really taking off to try to help to close some of the fossil fuel requirements and the green energy, that microgrids will start to proliferate. And in that environment, definitely 5G will be a requirement. I think also as utilities look at building out their own private networks, and we're seeing that to become a reality, that they're going to want to future-proof it to a certain extent and have a 5G capability. Again, I think they'll start to build out their radio access network infrastructure with a 5G roadmap. But even if they build that out, they've still got to have a device manufacturer that partners with them that has 5G devices. So I would anticipate that utilities will lag a little bit on 5G just because of for two things. One is that their applications are not necessarily requirement for the benefits that Carolyn brought forward with 5G. There's some of the other industries and some of the consumer products that may be more beneficial. And also in the fact that you've got to get, again, not to continue to harp, but you got to have those individuals who are manufacturing those end devices to build them in a 5G environment. So hopefully that helps to explain the answer to your question.
That was Steve Lowe, a national sales practice lead for utilities, if you hadn't guessed it, for AT&T. He's led AT&T's IoT and utility grid modernization efforts. Since Steve led us down the path of the utilities, let's hear from Ty Roberts. Ty, what do you think about the stuff that Steve had to say in terms of privatization of networks and so on, as well as the amount of enterprise IT budget? Caroline mentioned that 5 to 10% of the enterprise IT budget would be spent on conversion of 5G, but she also said that a significant amount of enterprise data would move into the cloud. How does that affect utilities?
So yeah, I think those are fantastic stats and aspirational to, especially when thinking about utilities to hit. So I think it's not a secret that utilities typically lag behind the technology curve for lots of reasons. I think there are requirements that their need to observe or to hit in order to make their business cases are pretty onerous. So the devices that they deploy today have to be in the field for 15 to 20 years, and so that they can realize the return on investment in many cases. And obviously, as critical infrastructure, they're security concerned. And those are all constraining factors. And there's always the sort of the old tendency of many utilities is to want to own and operate themselves. That's always, private has always been comfortable to them. But we absolutely do see that changing. So we see our customers, for certain, I'd say in the last 2 to 3 years, have really started turning corners in terms of embracing cloud models for deploying applications, embracing cloud models for realizing platforms that they can put their own applications or third-party applications on. So there's really, I think, with the adoption being so broad elsewhere in the world and in other verticals, sort of the mystique and the danger and the concern around cloud computing and cloud deployment is really starting to fall away. Of course, the other challenge the utilities have is what they're based on. They make money on a rate of return for assets that they put in the ground. So we've seen accounting rules and start to evolve and change, and different observations at the Public Utility Commission level, realizing and recognizing that, hey, let's find ways where we can capitalize recurring fees from a cloud service, for example, turn that into capital so that we can utilities can recognize a rate of return. So I think it's the financials and the commercials and how that's been regulated has been as much of a barrier as anything, but we're seeing that really fall away too. So I think the utilities industry, like everyone else, sees that there's so much value in embracing an edge compute approach. There's so many use cases they can realize with that and that alone. You can't realize by building a giant pile of data in a back office and sifting through it. That use these devices that are deployed at the edge, where the data resides, to make decisions, to perform analysis, and it's undeniable the value there. So it is absolutely changing.
All right, that was Ty Roberts, Vice President of Marketing and Network Solutions at Itron. Of course, Itron is one of the heavyweight players in the smart grid arena. Some of the things that are striking me here, I'm gonna bounce around a little bit because some of the things have been said and leading me towards thinking about a paper I read a long time ago by Eisenberg that was called The Dawn of the Stupid Network. And here we are today talking about smart networks. That was a landmark paper back in the day. Jon Vestal, Telstra, head of product architecture, big time into software-defined networks. Is a network smart enough to keep track of all this?
Hey, Stan, thanks. Sorry. Absolutely not. As carriers, we lag behind, much like the utilities. I thought that was a great comment. We lag behind technology severely, and slow to change, and kind of lethargic in the way that we approach technology, which isn't for a bad thing, right? When you pick up your telephone, you expect there to be dial tone. So there's reasons why carriers kind of move a little bit slow. But the networks that we have today, they're very static in their nature. They're very difficult to give any visibility to the core of the network to our customer. So trying to build a smart application on top of these legacy networks becomes extremely difficult. One of the things that I've been working on for the last 7-8 years, the joke is since I had hair, was the concept of our SDN. And we started this back at PacNet, and now it's carried through Telstra after we got acquired. And what it allows us to do is allows us to give direct access to our core, to our customer base. So customers can create slices, the buzzword of the year, I guess, as they need to across the core of our backbone. And I'm not a mobile guy, I can't spell 5G, so this is all fixed line Ethernet kind of services. But what we allow our customers to do is actually take and tie their applications directly into the core of the network. So now we can start to extend the intelligence that we have in the core of our network directly into the customer application. You marry those two things together and you get, kind of the ultimate in a smart application or a smart network, where the applications are controlling the network cores by themselves. And it gives a completely different look and feel to the way the applications perform. You start to introduce concepts of cloud native and things like that into network design and application design. And then I think it will empower and drive some of these new solutions. That being said, very few carriers are doing this at the moment. I'm happy to say that I was lucky enough to lead the team that built this within Telstra and PacNet. I think this will be the way of the future, but it's definitely not where we are at today.
Interesting. Well, a lot of that infrastructure that's programmable like that has to have specialized characteristics, right? Jesper Eriksson, Vice President of Product Management from NovFlow. I know that a lot of providers have specialized equipment in their network. What's going to change as we move towards this fully programmable, fully fluid network? You're muted.
Yeah. Hi, Stan. Thank you. I think the programmable networks will be key to increasing the velocity of new services. And one big change that we think or believe in here at NovFlow is that the old school was that new network functionality came with new RFCs and new protocols. And the problem with this old paradigm is really that RFCs and protocols don't evolve very quickly. Like Jon was mentioning, networks are very static and slow to evolve. And that really slows down the service innovation. But the new school, which is what we promote and we work with, is that new services can be created through software in the entire stack, all the way from the application and down to the switch silicon. So you basically have the switch, the application define the match action pipeline in the silicon. So we think this will be very important to speed up service, new service service introduction. And I can elaborate on some of the problems that we're working on with our networking technologies. One big area of that we're addressing is making the networks programmable using SRv6. So an SRv6 is an IETF standard for segment routing over IPv6. And this technology allows the network operator to direct its network traffic down to the flow level through a predefined set of waypoints and services as the traffic crosses the network. And so this is one way to add programmability to the network. And these services could be anything from like in the mobile networks, the mobile core, security appliances, anything that you want to chain in as the packet goes through your network. So we're working with carriers on this, as well as OEMs, to build this kind of solutions. Another area where programmable networks is very important for 5G is, Caroline, she talked about the main drivers for 5G, to have one network for IoT, video, low latency, mission critical services. How are you going to get all those services competing for the same resources on the same network, and then satisfy the SLAs, the unique SLAs of each service? And there's this wide gap in quality of service mechanism as defined by 3GPP and what's in IETF today. And to get an end-to-end experience, you need to be able to program your network to get that end-to-end SLI compliance. And we see this being done partly with granular QoS mechanism, but also with SRv6 to get the packets through the network in the right way.
Absolutely. Absolutely. It's a complex problem. Mar Taras, Vice President of Anterix. Love the private broadband networks. Love the Industry 4.0. Lots of opportunities there. You focus primarily on utilities, correct? But the Industry 4.0 concepts take the same concept and spread it across different verticals, right?
No, absolutely. So let me thank you for the invitation. I'm very honored to be sharing this panel with these distinguished fellows in the industry. Let me tell a little bit about Anterix and what we do, right? I'm the VP of Products at Anterix, and what we do is to empower the modernization of critical infrastructure by enabling private broadband networks. We are the largest holder of 900 spectrum nationwide, and traditionally this spectrum has been only for narrowband applications. But in the middle of these very sad and critical times, we had some green shots of good news. And on May 13, the FCC had an historical rulemaking where they enable 900 for broadband, and that was great news for utilities first and foremost, but also for the rest of critical infrastructure, right? Because utilities for the last 10, 12 years, right, had been looking for spectrum for them to deploy their broadband networks. I had the privilege of meeting Andres at the end of 2017, and he introduced me to the utility industry. So he's my godfather in the utility industry, and the problem by then was 4 years through the trade organizations, UTC, etc. The industry had been fighting to get spectrum. And actually, in 2020, in the middle of the chaos, now we have the FCC not only approving, 900 for broadband, which is a band that the utilities already are very familiar because they have a lot of their LMR applications, but also they have been auctioning the CBRS spectrum, right? Which is, Caroline has mentioned that, that's mid-band spectrum with a lot of bandwidth, which is going to allow all these entities that need mission critical use cases really create a private network with the right combination of a spectrum that will give them the flexibility to adapt to what they need, right? 900 is very good spectrum for field area networks, right? It's low band spectrum. It reaches very far, right? So if you have to cover a broad area, 900 is the right place to start. But 900 only has a 3x3 megahertz, right? Capacity can be constrained with some of the most bandwidth hungry use cases like video, etc. Right? So now you can complement with CBRS if you have other type of use cases that need much more bandwidth. So we believe we are at a very good point for the utilities to start coming up with their private LTE networks. Fully agree with what Steve and Ty have said. Right? It will be slow, but they are starting to experiment every day. Even today, there is another utility that has been granted an experimental license on 900 to test their own private LTE and testing new use cases. And agree, right? As they invest in private LTE, they had a future-proof platform to move towards 5G. And I fully agree with what Steve said, right? It's important that not only do these investments for the today's use cases, right, and for the today's business problems, which one of them is what you, Caroline, have said, the consolidation, a lot of workload in one network. Some of these utilities have up to 20 narrowband networks, one per each application that they had been putting along, the years that they have made grid modernization investments. But now they will have a platform where to integrate the much more real control use cases as they, integrate DRs and EVs and microgrids, as Steve has mentioned.
Absolutely. Carol, I'm gonna bounce this back to Carolyn for a minute here. I heard from your talk, I've heard everything that Mar said, and I've heard everything that Jesper said, and I've heard what John said about programmability, and Jesper said that it has to drive down into to support the velocity of services. These concepts have to move all the way down into the device. And you said that 75% of enterprise data is going to show up in the cloud, but we also heard from Ty and Steve that these utilities have got a 15 to 25 year technology life cycle issue. How do these things match up with the immediacy of network transformation?
Actually, Stan, what I said is actually 75% of data that enterprise will generate is actually at the edge, outside, consumed, generated, stored outside of the cloud. So that is actually the key element of it. So back to what you posed about utility companies, like Ty was saying that they might be moving behind some of the industrial and so on because they have a long history and it's also regulated industry. I have not had the opportunity to work a lot with the utility companies, but what we have seen is definitely the TCO models really important. Having the longevity of device and longevity of network is really important. So but at the same time, I also thought that healthcare would never go. I mean, talk about regulation. I mean, they probably are the heavy regulator. So when we first talked about this, we're like, oh, we don't want to touch healthcare. But guess what? With what's happening in the society today, we saw them being able and really step forward to say, how can I do a cap and grow? So the things that's already within, like it's within Wi-Fi and so on, we kept it. But new things that will add on, new services that add on, they started looking at these cellular network. And remember when the survey we've seen, as well as some of the things that we work with the Cleveland Clinic, the Houston Medical City, it's actually an add-on layer. So they don't really go and rip and replace anything. The CIOs typically not comfortable doing it. They really started layer on. So the ability to orchestrate, the ability to automate the process, have a single dashboard to show what's happening in the Wi-Fi, the Bluetooth side, and what's happening with the cellular side becomes really important to be able to manage that in a single dashboard. So the one thing that I didn't mention is that we actually, Intel has joined something called a 5G Open Innovation Lab up in Seattle with T-Mobile and NASA and Accenture. We started driving is that you have this 5G network, but we asked the enterprise to come in and develop their applications. So the type of application that come in are so different, like not at all. One of them was a supply chain for food, preventing a waste of food and secure the supply chain. Things that we never thought. We didn't go out and ask for this, but it's a incubator, has a backing of the VC, so we run through 2 cohorts per year. It's amazing. You see the things that come in. And Ty, just for you, I want to see if we can solicit things that come in for utility companies. so yeah, innovation doesn't stop because of type of industry. I think that's what we've learned.
This is absolutely fantastic and fascinating discussion. I want to relate this back to an application level vignette that I'm very familiar with. And it's really important here. You know, I work for Texas State University, and the university has a center that's federally funded that trains first responders in a number of scenarios. This training has, to date, no network component to it. Liam Quinn has been out to the alert. It's called the Alert Center. It's internationally recognized, very famous. Liam Quinn has been out to the Alert Center, and he's seen some of the stuff that they do out there, and he's seen some of the demonstrations of augmented and virtual reality that we're trying to rope into that. This particular application, it's timely because of the first responder issues, the constant issues with shooting. It also has a direct bearing on network structure, on quality of service, on SLA. If these things move into the network, they affect every one of you guys, including the utility folks. So I want to kind of hear from Liam's perspective, the utility of augmented and virtual reality, and then a little bit of a discussion around how that affects the Alert Center and things like remote training, which is really important even in COVID cases, right? Liam? Oh, you're muted.
Okay. Thanks, Dan. So it's this is very interesting for us, and we've got a brand within our commercial group. It's called the Ruggedized brand, and this is for first responders, military, DoD, other applications like that. And we're looking at putting 5G into the rugged notebooks and tablets, and specifically for case like you just described, Stan. And the benefit of that is it's not that we need it for email or documents. It's for the features of the network itself around latency and bandwidth and agility. But I think also there's an extensibility to having AR and VR as part of an extension of a mobile platform like that. Because again, first responders may have AR headsets, VR headsets, and you want all these things to be connected. So there's that sort of peer-to-peer connectivity that you need to be able to manage as well. one of the things that you will see more of is the more intelligence being applied to these mobile platforms. So rather than put a radio in there like we've done with 3G and 4G, we're going to put it in a very, very deliberate way of putting intelligence into the platform itself. So the platform is more agile in terms of making local decisions or decisions about what to do based on the criticality of the data, analyzing the data at source. Again, that's driving a lot of innovation around accelerator technology in the client platforms that we haven't had to do before, leveraging GPUs and CPUs or cores within the CPU architecture. There's other things like SmartNICs and FPGAs. So the notebooks that you see today and the notebooks you see tomorrow are going to be a lot different than what we've been using over the last number of years. And again, it's applying the right technology for the right use cases. So again, when the network is not reliable or is not all in place, I think there's the need to actually, what I describe as elasticity in the network itself. And that may be where in this case, a first responder device may compute a lot of data, but it also may leverage other assets around it, other nodes. So I think you're going to see more intelligence coming into the network where you have this elasticity effect of how to analyze data and what can be done locally or actually bodied off another system or other node in the network itself. So I think this is it's a very exciting time around this whole 5G space. And again, it's driving a lot of edge architecture changes that we haven't seen before based on capability of those features and parameters of a 5G network and network splicing.
Yeah, I want to stay on this subject of first responder training because it also has a bearing on the power industry and so on. Because there's a lot of issues, particularly like places like California where things catch fire. There's rolling brownouts and so on. If there are, and I'm going to throw this over to Steve and or Ty, if there are high-tech solutions like augmented reality and a 5G network for these first responders, how do they interface with the public network or with the private networks that those energy services providers manage? How does this work? We know that they have their own networks now. If it goes to more public scenario, how do the SLAs get dealt with? How does the quality of service get dealt with in that particular case?
So I'll take a first stab at this and then turn it over to Ty. But from AT&T perspective, many of you may have seen that AT&T recently won a bid from the federal government to support our first responders. And so we have our FirstNet network. And our FirstNet network is a priority network. It provides both priority and preemption for first responders. So those first responders such as fire, police, rescue, they have a network that's dedicated to them and the ability to make sure that their traffic's going to get through. So it gives them a layer of confidence that in those situations when we have natural disasters that are going to be able to communicate. And part of the requirement that we have with the federal government and winning this bid for the FirstNet network is that we have coverage. So, you know, we're spending billions of dollars to invest and make sure that we have that coverage. We're also working with the equipment manufacturers who are certifying their devices on this network. So we have a dedicated spectrum in band 14 that will be dedicated for those first responders use. But one of the reasons that we were successful in winning the bid, I believe, is because of the fact that we're actually allocating our entire commercial network to be available in those situations where we need it for those first responders. One thing that's good for the utilities is that utilities actually qualify as extended primary responders. So because they are critical in support of those first responders, we're finding that, you know, before that a rescue, fire, or maybe police go into a situation, they need to reach out to the water utility to make sure they have water pressure and they have the capable water for fire control, or they might need to make sure that the power lines have been de-energized. And so since utilities play such a critical role in first responders, they've been deemed as extended primary. So while they don't carry the exact same classification as a first responder on this FirstNet network, they do carry a very close second to it. So they do have the prioritization of their traffic so that you don't have the challenges of a commercial user such as ourselves congesting our network and not allowing them access to it. In the event that you have one of these natural disasters or one of these situations, the local incident manager can uplift them to have first responder capabilities. And what we're finding is that utilities, while they prefer a private network and private LTE networks, they definitely want to be able to have a resilient and redundancy and a backup plan. And that's one of the fastest pieces of the business I work with from an AT&T perspective is utilities and their adoption of this FirstNet network. So that's a little bit from an AT&T perspective, Stan. I'll let Ty kind of speak from an Itron perspective.
That's an outstanding answer. Actually, Ty, we got two things for you, Jess. One is the FirstNet stuff, but we've also got a question from the audience that has to do with use of Cisco field routers and so on. So you give it a little shot at FirstNet and so on, and then we'll go to the question from the audience.
Sure. So I think I'll take. So I appreciate Steve's answer. What I'll do is take the service level agreement part of that. So I think what we've done in a lot of solution or application providers like Itron to utilities is what we're accustomed to is. In a smart metering solution, which I'll use as a great example, we almost always have multiple network technologies in that tiered solution. So we'll be using an RF mesh or something for the last mile connectivity, but there's almost always a cellular component in the middle of that. So what our role is as the solution provider, the application provider is to have an SLA that we stand up for that's really inclusive of all of the network technologies that we're using between back office and whatever that endpoint might be, and sometimes this even goes into the home. So a model is to make that the responsibility of the application or the service provider is they know how to use one or more communication technologies to make their application perform and behave the way it needs to in the way that they need to stand up for it, and make them own that responsibility of standing up for the SLA. I think what's interesting to think about is especially now, if there's going to be a larger move by utilities into adopting private LTE-based solutions more ubiquitously, or certainly when 5G comes and is more broadly available, will the concept exist of the utility contracting with that communication service provider directly to provide sort of base levels of service, regardless of what applications sit on top of it. And the technology may be evolving to the point where that sort of level of risk is acceptable to the technology provider and the connectivity service provider to do that. So that might be something that happens going forward in the future. And then is there, on the Cisco question, is there a bit more detail that you could provide me?
I'll read it to you. Itron used Cisco field routers for earlier meter networks with the promise of these networks for multiple edge services to support utility functions beyond the meter. Itron then acquired Silver Spring. Yeah. And how are you now looking at your future network provision for utilities, network routers, use of 5G, or some combination?
Yeah, well, that's a great question. So I think, and it's suited well for this venue. I think what we're absolutely certain of is that a broad range of connectivity options are going to be required for the foreseeable future to address our customers, utilities, and cities' needs. And we want to provide choice in terms of who those providers are, whether that's public or private cellular, whether it's a particular networking technology provider or another. This is where Itron is increasingly becoming more open as far as that goes, and working with options that are favored by our customers. So we're certainly opening our portfolio up and being more integrative of other technologies and supporting various options as far as that goes.
There's another question that's a little more general than this. Let's push this to either John or Jesper. And Laura, I'm coming back to you in just a minute. Let's push this to either John or Jesper that talks about network-enabled device registration for particular purposes. As somebody who's been heavily involved in the development of HLRs and HSSs, I think I have an answer for this. But I want to hear from Jesper and John how the network that is now software defined is going to adapt to issues like this where people are registering different types of devices.
Yeah, John, you want to go first?
Yeah, thanks. Throw me under the bus, Jesper. Yeah, it's an interesting question. I actually haven't thought about it. I saw the question pop up. I think, you know, the value of having that programmable edge and even a programmable core lets you kind of do anything your mind can come up with. And we've come up with some crazy things. And it's no secret we use NovFlow switches and we've pushed them to their edge. Jesper started to kill me sometimes on some of the stuff we're asking for. But you know, as much as we can push into the network and offload traditional ways of authenticating a device, for example, I think allows us to provide a better service to the customer. For one, we can do it closer to the customer edge. We don't have to carry that traffic all the way across the backbone to some authentication server and then hand it back again. And I would go, it's in the discussion that we were having on first responders, it kind of fits into that same category there. I think it was Liam, but the idea that having a platform actually control, looking at 5G more at the platform level than the actual radio level, kind of fits into that same category where we can start to couple the different networks together, and we can start to tie that platform or application into the actual performance of the service that we're looking for and how we create that individual services for the customer. It does mean breaking every concept we've ever thought of. For example, I could see a use case in first responders where we want to be able to, in a traditional sense, multicast that same video stream to multiple screens. Being able to do that natively in the hardware without actually multicasting, because that may or may not fit all network types, becomes an interesting use case for it. Being able to have that device register into that stream, so a device can say, I want to see this particular live stream, and be able to deliver that device again with all the standard authentication and authorization rules wrapped around it. All of that now becomes possible as we start to look at these programmable switches and these programmable devices that we can start to run either at the edge or at the core. Jesper?
Okay, thanks, John. Yeah, I'm going to spin a little towards the security part. You know, when you have a lot of devices coming onto your network, of course you have to authenticate them, but then also you have the trust issue. Can you really trust them? And you know, let's say you have millions of IoT devices out there. So what we see is that the operators, the carriers, they're protecting their networks not only from the internet and other networks that they connect to, but also actually towards their own subscribers and their own you know, whatever devices are hooked up to their network. And programmable networks, you know, enables this, you know, the ability to insert security services in traffic coming in from the access before it hits your core is you know, becomes very important. And so I think this, yeah, the security clearly plays in, and by having a programmable network too, you know, you define what the network, how the network responds, and there is some inherent security through having a complete control over the stack all the way to the silicon, how the silicon processes the packet. And unless you put in a rule in that match action pipeline, the packet is not processed. You know, you're minimizing the attack surface by eliminating hundreds of protocols. You can also replicate attacks in one place across your entire network, you know, everywhere by pushing those rules everywhere. And yeah, that's what I wanted to add.
Okay, Mar. Security, edge-defined services, edge processing, velocity of services, SLAs, but how does this all work together with resiliency and security in mission-critical sectors? I have some concerns.
So I think it has been said throughout this conversation. You know, one of the things why utilities and mission critical tend to go to private networks, right, is because they can isolate these networks from the commercial carriers, where you know first and foremost, they are connected to the internet, right? So, by creating an air gap network, you lower your surface attack, so that's one of the premises that we are working with. On top of that, right, to the talk that we were having about mission critical use cases and having full control and visibility of all these packets, right? Until we don't get to this programmable core that Jon has mentioned, and we start exposing those features to folks that really need to have, closed loop applications, real-time applications, and they need to see, by the second or millisecond where that package is, right? Private network is a good solution for these folks. But one of the things that I want to drive the attention, that it's relative to edge compute, etc., is that putting LTE in the hands of utilities, right? It opens them a full suite of connectivity capabilities that they had not had in the past, right? And there is, usually what we have seen is that IT gets to say, hey, I need a network, bring me the network. They build a network, and by default, that application rides on that network. At Anterix, we are doing a collaboration with NREL, the National Renewable Energy Lab, where we brought them a private LTE capability with the idea of migrating it to 5G, because when they are working in all their advanced integration of DR at massive scale and doing all the algorithms on how to balance the load and keep the network stable, they assume that the connectivity was there, that it was a pipe, that it was going to be there, available to them with, a pipe. We have worked with them to really educate them about what are the capabilities of private LTE with traffic prioritization, etc. And there was an aha moment saying, wow, the more I understand the capabilities of my network, the better I can optimize my use cases on top of that. So I think there is a real opportunity here to bridge a couple of walls, the OT wall that they are really thinking about how to solve the power problems, right? And the IT wall and networking, and converge them together, because the outcomes are going to be, better, faster, more innovative, right? NREL has developed this model of the local compute area for the power devices and the central compute center for some of the data. And they have this model of some of the data, as Carol said, is going to be processed at the edge of the grid, and only certain things will go back to the command center. Well, now with 5G, and I think virtualizations allows for that also in 4G, we can start working with making sure that these models that the power engineers are working on can actually be implemented, because the connectivity layer is flexible enough to meet those requirements that they are putting in their forward-looking energy frameworks. So there is a lot of opportunity to collaborate between the two walls.
Ty, what do you think about that? Long, thin network with smarts at the edge, or big fat network with smarts in the middle in the utilities? What?
So we're, as Itron, have invested pretty significantly in being able to distribute intelligence all the way to the edge. So our latest generation of devices, electricity meters in particular, have a distributed application platform built into them. So they're your traditional meter that sits on the side of your house, but they have an application platform built inside where utility can download different applications that they build, that we build, that third parties build to run at the edge. And that's really, I think, as Caroline said, off the top, is that there's so much data that's resident in sensors and devices that are deployed today. And a smart meter, for example, There's 32 kilohertz of data that it's generating and essentially throwing away continuously. So that's a ton of information that can be leveraged and used to create value and insights that there's really no practical way to backhaul all of that and store it somewhere. So I think it must be done at all levels of the network, including at the very edge. I think that's there's a true realization that that's where the future is, and utilities are starting to really embrace that as well.
Steve, you agree with that? You want people in the utility industry fiddling and reconfiguring your network on the fly?
Well, we have software-defined networks, so that's something that's not new to AT&T. We definitely support the ability for the end user to determine the bandwidth requirements ad hoc that they'll be able to need and want, and I think that's the flexibility we want to be able to provide. But Stan, if you don't mind, I'd just like to step back to the cybersecurity comment real quickly. I know Todd mentioned earlier about the fact that utilities are looking to more cloud-based services, and one of the challenges we've had in the past is the fact that the way they've been funded, and they're funded with a rate case where that that they are capital intense. Normally the capital gets approved, but the operational expense doesn't. But something I wanted to share that I mentioned the other day is around a docket that FERC released just recently, and that's AD 2019. And in that docket, they have suggested that to look at incentives to invest in cybersecurity. And in doing so, they're recommending to take a look at if you invest in a cybersecurity software or devices or technology to help with cybersecurity, then they will consider that as a capital expense for a 5-year period. So I think that's going to be a game changer in a way that utilities look at cybersecurity, and it may be the momentum shift that we're looking for them to move from having to be particularly capital intense to more looking at TCO. In the past, I don't think they really looked at the total cost of ownership. They've looked at, can I do it all under capital because I earn a rate of return? So I think just wanted to piggyback on cybersecurity and Ty's earlier comments about the shift. And usually in a utility conference, I make the joke that utilities are changing exponentially, which is funny to have those two words in the same sentence. But I do think that they are rapidly changing, and agree with the comments about cybersecurity is doing this. NERC SIP, the requirements from a NERC SIP perspective for cybersecurity. But this docket that FERC just released, I think if it's a white paper, I think if it gets approved, it'll really change the way that utilities look at cybersecurity. They look at hosted distributed intelligence and the way they do business. So I just wanted to throw that in when I had a chance.
Liam, you think a 5-year window for cybersecurity makes sense?
Say that again, Stan?
Do you think a 5-year window for cybersecurity makes sense? Can you keep up? Can we keep up with the attackers if we have a 5-year roll on cybersecurity?
Well, we're speaking for Dell, we've got a big team across all our businesses working on security, and it's trying to keep ahead of all the attacks, and it's only going to continue. So, and I think it's something that it's a priority for us, and I'm sure it's a priority for every member on the panel here as well, that security is first and foremost the bedrock of what we do. And we've actually done a lot of unique things. I'm just going to pivot here slightly from the client perspective. We have layers below the OS and below the processor that we've developed over the last decade, where we have encryption, key management. So if you think of that as like 4 or 5 floors below the ground that you see in a building, we continue to innovate way down below that. So we can go in and manage or change or take over a system without the OS, without even being booted. But there's also security in supply chain, and that's a big one for us right now. Even all the components that go into a system. And there's certain customers that actually are driving that as a key criteria of where systems are built, where the silicon is developed, where the software is developed, root of trust, traceability. So there's a lot of security. Is not just one area; it's across multiple areas. So it's a big area. Not about
John, I've worked with out-of-band networks before. Liam just stepped all over the out-of-band network. The network's still got to support the out-of-band network. What do you think about that?
Yeah, you know, everyone talks about privatization of the networks and all these other things, but at the end of the day, it's got to run over infrastructure that's going to be owned by somebody, right? So I don't see it's going away soon. The security aspect, I think, is interesting because we need to look at security at all layers. We have a tendency to only look at hardening the edge from an attack profile and let the core be a little bit soft. And I think that that's been proven multiple times to be flawed. When we can actually start to extend the security paradigm directly into the devices carrying the packets, we can actually prevent those bad packets, for lack of a better word, from traversing the network at all. So why even carry them over to a cleaning farm or a scrubbing farm if we can just deal with them directly at the edge? And it doesn't really matter if it's in the mobile edge or if it's in the fixed line edge. Point is that as soon as we see a packet, we can start to make decisions on those packets. And we don't, I think Jesper said something interesting, and that is, as a carrier, we don't trust our customers. And that sounds really bad. But the truth is everything's potentially a hostile environment coming into us. And we really have to focus on securing and evaluating every single bit that comes into the network to make sure that it is actually a proper bit, be it directed at our own infrastructure, be it directed at customer infrastructure.
That's why you typically keep the control plane physically separate from the bearer plane, right?
we do. There's absolute value in separating those two out. It's really hard to jump and cross the line between the control plane and the data plane. And you end up building completely isolated networks in the control planes. Pisses off my software engineers who are used to having internet access to everything, and then all of a sudden on a smart, on a programmable device, they can't do an app update, for example, because there's no path to the internet. But you absolutely need to be able to keep those two separations, and I think that's one of the positives that we've seen come out of this whole separation control plane and data plane.
Yeah, we're going to run a couple minutes long. I hope that's okay with everybody. Jesper, what do you think about optimizing the actual architecture of the devices with respect to the threat vectors that they may face?
Let me unmute here. Yeah, let me think about that one. The actual devices. Are you saying the network devices or the end devices?
Primarily the network devices.
Yeah. So absolutely, you need to, and it will go along the lines that Jon was mentioning, that you separate the control from the user plane, but also that you make sure that your network device you program it to do only what it's supposed to do, and that means you need to eliminate a lot of functionality that you don't use, and that's just latent, and that could be part of an attack surface. If you take a typical router today, you may have hundreds of protocols in it that are basically attack surfaces, and by programming your device to only do what you want it to do and that your application needs it to do, you minimize that attack surface. I think that's one area that you do it. And then you also make sure that you add network services in multiple layers in your network, or security services in multiple layers of your network, like Jon was saying. So as the packet traverses your network, you run the packet through various security services. First you have DDoS, then you have firewall, and then other things. So,
Mar, what do you think about that? What do you think about that, Mar? With if I've got a separate network, how does my security interwork with the next guys?
Well, if you have a separate network, by definition, you don't have that interconnection, right? What is clear is that having a complete air-gapped network is going to be difficult. To what Jon said, at the end of the day, all the vendors are going to bring their software updates, via a public network. So, I agree with what has been said here, right? We will have to have mechanisms to really inspect every packet that goes through. We will have to have, security not only on the network devices, but also on the edge devices that really process everything. And, in the wireless side, right, we will have to make sure that, the RF aspect doesn't get tampered, and we can have some bad actors intruding as that bad as a fake device into the network. So cybersecurity is going to be an effort that that the industry needs to fully work together. And a lot of sharing of best practices, and every attack that has happened, making sure that others understand what can happen and replicate. But I understand that as an industry, right, all these mechanisms are already in place. What we need to make sure is that as the technologies evolve, right, we as an industry even detect earlier where are we building vulnerabilities, because we will be opening up vulnerabilities with the new.
Absolutely. Caroline, you get the last word. It sounds to me like a lot of the AI that's going on the edge of these new networks is going to be focused on security mitigation. Yeah?
I can see that, yeah, because security definitely, especially if you're going to penetrate something like utilities, security going to be foremost in everybody's mind. I don't want my utility company get hacked, for sure.
Well, we're a little bit over time. I apologize for running long, but I mean, honestly, I could go on for days with this. This is absolutely fascinating. Started with a spectacular presentation from Caroline. Really appreciate that. Outstanding discussion with the panel members. Really appreciate that. Thank you very much, folks, for joining this afternoon. And I hope it was as beneficial to you as it was to me, because now I'm going to go find a bucket of cold water and stick my head in it. Yeah, thank you very much.
Thank you.
Thank you. Thank you very much.
Thank you, Sam.
Bye.
Thank you.
Bye.